this course, again, it is data communication and network. So we are going to learn about how computers, basically, mainly computers, talk to each other. How these computers and how data is being exchanged from among computers. You still remember, back in the, if you study your computer architecture, then you know that the birth of the computer system, then the creation of the microprocessor, the entire computer system itself, they are be able to process data, everything in digital, in 1 and 0. And it is wonderful to have a computer that will be able to carry out a lot of complicated tasks. But again, all this processing is actually within the computer itself. We will call it within the box. So now people are not happy. People are not happy by just allowing data to be just keep within the box itself. So they would like to be able to share data from device to device. So this is actually sharing data among the computers, amongst the world of computers. But before the computers come into the picture, human already started their own network. So human already started their own communication network, for example, telephone network. So telephone network is a very good example where human is being able to use technology to actually communicate. So human voice has been delivered all the way from one point to another point across the globe. And then you can talk to anyone as long as they are connected to a telephone network. So at one point, the telephone network was being called the world's most complicated machine. But that was last time, As computer come into our life, then we start to do a lot of things using computers. You start to use email. Okay, nowadays you are using what? You are using the smartphone. The more smartphone you are using, your smartphone is a computer. As you can see, it's compliant to the von Neumann architecture. It's come with a microprocessor. It has got RAM, storage, and other stuff. So basically, it is a computer that you are bringing every day. So I can safely say, the smartphone penetration or the mobile phone penetration is getting higher and higher. So everyone is sending digital data across. So when you're actually messaging with your friend, you're visiting your social media, they are all involving the exchange of data. I would say, be more specific, the exchange of digital data. 1 and 0 we are talking about here. That's why when we call it a data network or data communication, we are basically trying to send 1 and 0 across the network, you see. So it is not the analog human voice. Our voice is analog. You are using a microphone to capture the voice. You can record your voice using a cassette tape. You can record them into MP3 file. When you record them into MP3, they become digital. But if you record them using some magnetic media, then the original form of your voice is still in analog, you see. And the same happened to video. You still remember long times ago, you are using video tape to actually record video. So those are in analog format. And today's you are not using video tape anymore. You are using memory card, you see. When you actually capture your video using a camcorder, you are using memory card, something like SD card, or even last time they use compact flash, all those stuff. But now SD card is more popular. So you are using SD card to capture all your videos. So what is being stored inside your SD card? Those are digital data. And as long as they are digital data, they come in the form of 1 and 0. Okay, as simple as that. So this course, we're talking about a data communication and network. So we're talking about solely how to deliver 1 and 0 across from one computer to another computer. That include from your smartphone to another server, another computers over the other end. So as long as the end device is actually a computer system, then this is actually applied. And you can start to see that more and more computer devices, the population of the computer devices has increased drastically in the past 10 years. Now all of you has got a computers, more than one computer. Some of you wearing smartwatch. That is also a computer. Some of you wearing, getting a smartphone. Some of you having all those digital gadgets around you. So those are the device, right? So we are talking about this kind of network. Okay, so let's go down to the syllabus, I think I would like to highlight on the syllabus. Why? Because this course has been talking about breaking into smaller parts. You see, the entire course itself has been breaking into smaller parts. So we are trying to break it into according to layers. Later, you will look into a network model. So everything can be described using a network model. So this network model consists of multiple layers. So the standard reference model has got 7 layers, but the practical one is actually only come with 5 layers. The one that we use every day. What kind of network that we use every day? It is the internet. The internet is the network that we use every day, isn't it? You cannot live without internet now, you see. So what kind of network models our internet is based on? The internet is based on the TCP/IP model. So you're gonna remember TCP/IP for the rest of your life, because the entire internet is work based on TCP/IP, and TCP/IP only has got 5 layers. So if you look at our course syllabus here, we have many learning units. You can see that starting from learning unit number 3, we talk about layer 1, layer 1, layer 1, layer 1, because layer 1 is one of the most complicated, I would say, one of the most complicated layers, which is involving signaling. You know, signaling means electrical signal. How do you send your information? You have to use electrical signal. You have to use something to send, right? You must have a transport. Just like when you want to, come from, come from KL to Kuching, you have to have a means of transport. So what is your means of transport? You use airplane. So for you to deliver data, you need to have that means of transport for your data as well. So what is that? There has to be some sort of electrical signal. Telephone network also using electrical signal to carry the data. Same thing. So I would say layer 1 and layer 2 is probably 2 of the most complicated networks layer that has consists of a lot of things. Okay, so this one is very much towards the hardware. Layer 1 is very much towards the hardware. Then layer 2 is slightly go into the software already. Then layer 3, layer 4. Okay, then last one is actually the layer 5, or sometimes you want to call it layer 7, because depending on which model you are talking about. The standard reference model has got 7 layers. The highest layer is always application, which is your software applications lah. Something like your web browser, okay, your Firefox lah, your Chrome lah, or those are actually network application, which is actually sit at layer 7. But if you are using TCP/IP model, then they sit at layer 5 lah. Okay, so layer 5 and layer 7, depending on which model you are talking about, they are basically the same. So I want you to look at this syllabus here. Always, every time when you do a study, so always be very clear about which layer that we are talking about, you see. So as long as you don't get yourself confused about the layer, then it's very easy for you to structure your learning, your knowledge, you see. You cannot lump everything together because you will get confused, right? So if you look at layer 3, learning unit 3, you will see transmission media. Transmission media itself is talking about cabling. You can have different type of cable, but nowadays you don't like cable, you want to go wireless. So wireless is also one type of transmission media. And if you look at data and signal, learning unit number 4, data and signal is actually how do you represent your 1 and 0 using electrical signal. You must have a mean to represent. You cannot just say, okay, I use electricity to send my data. But how, you see, how does electricity can be used to send 1 and 0? So this is being described in learning unit number 4. Then later we look at different type of transmission. We have digital transmission, we have analog transmission. So what is digital and analog? Digital is 1 and 0. Analog is not 1 and 0. Analog is something like continuous. Anything that is non-digital is analog. Let's put it this way. The original form is always analog. So we have 2 types of transmission. Meaning to say, if I actually send an email to you, then there is actually a digital transmission because my data is in digital format. But now if I make a phone call to you, I'm not talking about using a WhatsApp call. I say using ordinary telephone set to call you, then there is an analog transmission. I know nowadays you can make phone call using your WhatsApps lah, using all the different type of app to make call. But when you use your app to make call, so those become digital transmission, right? So we are talking about the most original form of telephone, the ancient telephone system. So when you call someone, when your voice travels through the network, so that is actually analog transmission. Then later come to learning unit number 6, then we talk about bandwidth utilization. You really care about how fast your network is going to deliver data, right? So you care, you say, my network is slow, that's why my, my things got, stuck, jammed, it's not smooth. So you will complain about this. So this is actually the part where we talk about bandwidth utilization. So how much bandwidth do you have and how do you fully utilize the network bandwidth? Different type of transmission media will be able to offer you different type of bandwidth. For example, nowadays everyone talk about fiber optics, right? You say fiber is the best. You see, even at your home, you say I'm using Unify. Unify running on fiber, you get 100, 300, 500, and 800 megabit per second. So in order for you to achieve that kind of speed, last time it was not possible without fiber. Last time, you still remember, some of you maybe still remember, TM used to launch the, broadband package called Streamix. So if you are using on Streamix, you are not using fiber optics as the transmission means. You are using what we call copper cable. If you're using copper cable, those telephone cables, they come in copper, copper wire. So those are actually the copper cable, and they cannot give you that much of bandwidth. Okay, compared to today, if you are using fiber optics, you have, massive amount of bandwidth that you can utilize today. So in learning unit number 6, we talk about bandwidth. And then number 7, learning unit number 7, we talk about switching. And this switching is always talking about sharing. If you want to save costs, your network is cheap, you cannot lay cable to everyone's house, so many cables. Right, so you cannot lay so many cable. You just lay one cable to your house, and you can be able to, talk to so many people. Why that is possible is because of sharing. And then one of the technique of sharing is called switching. Switching, or what we call routing. Okay? Those are actually fall under the learning unit number 7. So we'll learn about how network is being shared. If it is not shared, it's going to be very expensive, right? So just like when you actually get on an aeroplane, you also share with other people. You share with 100 to 200 people on the same plane. Then you can get to pay a little on your tickets, you see. Otherwise, if you don't want to share, you want a dedicated flight, then you have to pay the cost of the entire chartered flight. So in network, we are very much focused on sharing. How do we share? And apart from sharing, then we look into error detection and correction, because when you transmit data over the network, you cannot avoid of errors, you see. There are always accidents, right? Even if you travel on the road, you tend to get accident, Accident do happen, and you do not know when they are going to happen. So these are the problem. So on the data network itself, it's the same thing. Error is going to happen, but when error happen, how do you deal with it, How do you do correction? How do you detect there is an error? Then how do you do correction on the error itself? So that your data that has been damaged can be recovered. Okay, you can get back your original data. Then after that, we talk about learning unit number 9. We talk about data flow control. What is this data flow about? This data flow is talking about, how fast should you send, you see. If you have a transmitter, you have a receiver, right? So when I talk to you, and then you are listening, when I speak, I am the transmitter. And then when you are just listening, you are the receiver. So how fast should I talk? How slow should I talk? That is also need to be agreeable between the transmitter and receiver. So this kind of arrangement is what we call the data flow control. So how fast should they transmit? You may say, as fast as possible. Why do you want to wait? If I talk very, very, very fast, then you cannot hear what I'm talking about, right? So it's the same thing here. So I need to slow down. If you are a slow listener, so I have to slow down. I cannot talk too fast, right? So this is what we call an agreement. is called the flow control between the transmitter and the receiver. Okay, so that's why I say the entire network stack is kind of complicated, but it is understandable, right? Then when come to learning number 10, we look at different type of network technology. They have different network standard here. We have Ethernet network, and then we also have, we're going to also talk about wireless network as well. Ethernet itself is a standard for local area networks. Later you will know what is local area networks. But Ethernet is one of the standard, and it's also defined in layer 1 and layer 2. Then later we go up to layer number 3, which is we talk about logical addressing. So this is another layer that is higher. So it's actually very much concerned about address. So when you want to send some data to someone, have an address, right? If I want to send you something, I must at least know your address. So the same happen to your data, and your data is going to be put into packets, put into packets. So your data is going to be put into many smaller packets, and each of the packet you have to write the address and then send into the network. So the network system will be able to read the address and then route your data packet to the destination. So that's why we need every data packets to have an address. So this is all defined in layer 3, which is actually the logical addressing. Of course, layer 2, we do have some address. Okay, we were going to discover that as well. But layer 3 address is more, I would say, international. Okay, because your entire internet is based on this layer 3 address. If you want to send something in the internet, it's all based on your layer 3 logical address. And then we go up to layer number 4. Layer number 4 is basically a process-to-process delivery. What does that mean? It's something like a checker, you see. So when you actually send something across, so this layer 4 is going to make sure the data packets is being delivered successfully. For example, a consignment of packets. Let's say this time the consignment of packet is actually consists of 200 packets. So these 200 packets is actually a file. Okay, your file is being break down. You want to send a file to your friend, right? So your file has been break down into 200 different packets. So each of the packet is going to be put with an address and then send it into the network. So this layer 4 is going to make sure that all the 200 packets is going to be delivered successfully and arrive and being received by the receiver. So when the receiver receives successfully all the 200 packets, then his job is done at layer 4. Okay, it's something like a higher level monitoring to make sure that your data is being delivered in a reliable manner. Okay, you have reliable data delivery. You do not miss. You send 200 packets, not only a few missing, that is not acceptable. So layer 4 is going to make sure that nothing is missing. Then how about if something really missing? So layer 4 is going to be responsible, telling the lower layer to retransmit again, send again if it is missing. So it will make sure reliable, right? It will make sure all the data sent from one end to another end is 100% reliable. If it is got missing packet, then it will instruct the lower layer to retransmit those missing packets again. So those are actually, that's why I said, if you can see, all these layers, that each of them has got their own basic functionality, right? So lastly, is actually the application layers, which is actually pretty straightforward. You have been using it every day. Layer, network application layer is actually the layer that is closest to the human. Okay, closest to us. We are using an email client. We are using the internet browser. So those are actually sitting on the network application layer, right? So I want you to be able to imagine all this. Later, when we go into learning unit number 2, you will start to see those network model, and then they're all divided into different layer. So different layer will have different functionality. So when we study all these different layers, so don't get yourself confused. I want you to come back and refer, and then they are all put under the same umbrella. Yeah, they are all the same, right? Okay, this one not important. Okay, so for this one, for this learning number one, it's just very much like an introduction. So we talk about data communication, what is network, what is the internet, okay, and then what is the protocol and standard, right? So here, data communication is basically what, is how data is being communicated. This is actually at very low level. This is what we talk about signaling, signal. Signal, when we talk about signal, is always related to electrical signal. We use electrical signals to carry our data. You know that current can flow through any conductor, right? So it is the same thing. So we are going to use this current to actually carry 1 and 0. So this is all defined under data communication. Then when we go up to the a little bit higher layers, we talk about the network. The network is basically you create group of computers that group together, okay? Different group of computers that will form a network. Different type of grouping. I'm talking about, you're going to see the different grouping again. Then they will form a computer network. So this is a bit higher layer. And the internet is actually one example of all the network interlinked together. And there's a name for internet, is that the internet is actually a network of network. Okay, the internet is a network of network. So you have so many network connect together and then form a bigger network. So this bigger network, we call it the internet. So it is actually the network that we are using today for a lot of our application. I think 99%, okay, not for the end user, 99% of our network is actually based on the internet. And there is not only one network technology here. See, the internet is just one of them. We have so many different types. It just happened that they are not popular. The most popular one is the internet, which is based on TCP IP. Okay, so take TCP IP network, it's become so popular nowadays. That's why we tend to not very interested with other type of network technology. Okay, it's overwhelming. And then we need to look at protocol and standard. So why do we need to have protocol? Then why do we need to have standard? So what is protocol? Protocol in short is actually a language. If I want to talk to you, we might have to use the same protocol, right? For example, now I'm talking to you. I can talk to you because we are using the same protocol. Because I use English and you understand English. So that is our protocol. Okay, we are using the same language. That's why you can understand. So suddenly I speak Spanish. Then you do not understand Spanish. Then we are on the different protocol. So we couldn't understand each other. So computer system is the same. Computer communication is the same thing. They have to be, the two computer has to be using the same protocol. That's why I say all the computer internet, all the computer in the internet are actually using the same protocol. And then this protocol is what we call the TCP IP. The TCP IP is the only protocol that can be used for the internet. If your computer is using other protocol, then most likely your computer cannot communicate with any of the computers in the internet because you are running a different protocol. And standard, what are the standards? Important standards basically is just to standardize lah. For example, you buying, I give you a very simple example. For example, you buying a monitor, you buying a keyboard, right? Then you want to plug into your computers. Does it work? You say it's very easy. I just buy one and then plug into the USB port. It just works, just like that. How come it can work? It's all manufactured by different people. They're all manufactured by different manufacturers, but how sure are you that when you buy a keyboard, it is going to work with your computer? That is because of standardization. They all follow the same standard. That's why you can be very sure that you buy this keyboard, even though it is not made by the same manufacturer, your keyboard will still be working. That's why standard is very important. Okay, you are buying different type of network adapter, different type of network equipment. When you put them together, they should work seamlessly without any problem. That's why protocol and standard are very important in data communication and network. Right? So basic model of communication, very easy. You must have a source and destination. Source is the sender, destination is the receiver. So for you to send it over, you must have a channel. So your message must pass through a channel. This channel here is actually a wireless, and the air is actually the channel. So you are just shouting. So your voice is traveled through the air, which is the medium, the channel, then pass through the air and then reach the destination. But if you go to outer space, there is no air. So when you shout at someone, then your message will never get transported because there is no medium, there is no channels available. In the outer space, it is vacuum. There's no air, you see? That's why your message will not get delivered using your voice. You can use some other mean like electromagnetic wave, which can travel through vacuum. So that is not a problem. But if you want to use your voice, then you must make sure you have some air as a transport medium. Right? So it's actually the model, the concept is very straightforward. And these are some of the application. Fine question, I leave it to you. So I think we have to explain this one. Data communication is actually very much looking at low layer data representation. You know, how do you represent 1 and 0 using electrical signal? And then network is actually higher layers, a grouping of computers into different type of grouping. You will form different type of networks. And in order for that to happen, you need to have the protocol in place as well as the standard in place. Okay. So this one is straightforward. So I will not talk too much. And when we build a network, okay, there are a few things that we care about. Is either we care about the delivery of our data, right? So data must be received by the intended user or the intended device. And we talk about accuracy. System must deliver the data accurately without any mistake. Okay, so those are actually the requirement. And then the timeliness. You cannot take ages to deliver data, you see. You have to be, just like when you order something, when you send something using Postlaju. If Postlaju supposed to take 1 day or 2 days to deliver you the goods, then that is called timely delivery. But if the Postlaju service, you only take 1 or 2 weeks, so you are not happy, you see. So you're not happy, so it is not timely, so it's actually beyond, the delay is too long. Okay, so when you design a network, timeliness is one of the criteria. Another one is a criteria is actually jitter. Jitter is actually referring to some distortion. Okay, some distortion that happen to your data packets along the way, so they will actually create different delay, different delays in arrival. For example, you and your friends, okay, you and your friend depart from the Unimas campus, and you want to go to the same destination, but you are using a bus. Then your friend is driving a car, and your another friend is using a motorcycle. So different people will have arrived at different times. So those are actually the jitter that we are talking about. The delay is always not the same all the time. So the delay will always be a variation for all the different data packets. So not all the data packets is going to experience the same type of delay. So this is what we call jitter. Right? And again, this is the basic components. Like if you look at the 5 components of this, first you must have the sender and receiver. Second, you must have the medium. Then you must have the message, and then you must have the protocol. The protocol must be the same for both computers. The sender and receiver must have the same protocol. If they are not operating on the same protocol, most likely they cannot understand each other. Then your communication will not be successful. Okay, and this one, we were going to talk about the protocol architecture, more details in our network layers architecture, such as the OSI 7 layers and the TCP/IP layers or TCP/IP model, which is actually the one that we are using now for the internet. OSI 7 layer is just a reference, okay? So OSI 7 layer is a superset. So this TCP/IP model is a subset. So OSI 7 layer is just for you to reference. Ideally, you should have 7 layers, but sometimes you can use less than 7 layers for your network architecture. So I'm not going to talk about this one. So as you can see, the networks is actually very complicated. You can have all the different networks just interlink to each other. So easy, you just switch on, then you are part of the network already. So these are not magic. These are not magic. This one have to thanks to the TCP/IP model, so that you don't have to really set up too many things for you to be part of the networks, for you to be part of the internet, the larger internet, so you can talk to anyone, you see. So it's so convenient thanks to TCP/IP. Then later we will study what TCP/IP has done for us. All right, but today we are talking about something that is higher layers, right? So what is a network? Network is a set of devices or nodes are connected in the media link. So you might have something to interconnect them, link them together. So what is a node? A node can be a computer, can be a printer, can be your smartphone, can be a laptop, can be your smartwatch, can be your IoT, okay? Can be any of your IoT device. Okay, so if you have IoT device, such as your CCTV cameras, your sensor and all the stuff, so those also can be called as a node. And what is communication channel here? It's actually basically the link that connecting all the devices. Then what kind of link? It can be cable. What type of cable? Is it copper or is it fiber or is it coaxial? Okay, you have different type of option. And then some people say, I don't want to see physical cable. If you don't want to see physical cable, you can use wireless transmission. Okay, wireless transmission can establish connections without any physical cable. So network criteria that we always evaluate to see how good is your network, how good is your network perform. We always look at the performance in terms of the hardware and the software and the transmission medium as well as the user. And we also look at not only just the performance of the network itself, but we look at the reliability. Sometimes when your networks, when your hardware is high performance, doesn't mean that they are always reliable. For example, you get a Ferrari, okay, there is a very high performance set of hardware, but when you actually run too fast on a Ferrari on our highway quality is not that good. So you might get into accident. So when your Ferrari get into accident, then you're going to have problem with reliability. So it is not reliable using Ferrari to run so fast on our type of highway. Is going to, chances to pick up accident is very high, right? So that's why reliability is always associated to frequency of failure. Okay, how soon can you recover from the from the error and so on. And another concern about data communication and network is that the security. So when you send your data out, so how do you make sure that your data is not being seen by other people? You are sending something private and confidential. So how do you ensure that? Okay, the confidentiality or the security of your data so that other people cannot see, only you can see or your friend can see. And then how about the threat coming from the viruses? Nowadays a lot of viruses around, so the viruses is going to come and cause damage to your system. So when a viruses causes damage to your system, you're going to experience losses. For some of you who are using your computer to to type your assignment or your project, when a virus deleted your assignment, so you're going to cry and then you're going to tell your lecturers that, oh, my assignment is being destroyed by virus. So that kind of things, you're going to make your life very difficult. And unauthorized access as well. So nowadays we do a lot of online banking. So if your account, being accessed by some unauthorized person, someone hack into your account, someone hack your password, so someone get hold of your password, they will be able to log into your account. Then, your money is not secure. So it's actually same thing. Your data, your money, same. So those are actually fall under security. All right, so data communication, 3 network criteria that we always care about is performance, reliability, as well as security. And in terms of networks, they can be divided into different categories. We can see network in different categories. One is actually the type of connection. What type of connection do we have? And then what kind of physical topology? Physical topology means the physical layout of your network. Then we'll look into transmission mode. So what kind of transmission mode can we have? Okay, how should the transmission behave? And we look at different category of networks, and we can also look at inter-network. Inter-network, basically you link all the network together. This is what we call inter-network. You send data going across different type of network technology. So that is inter-network. And for your information, we have so many different type of network technologies around. But of course, some are more popular, some are less popular. Okay, so yeah, that's why I say it's a very huge topic. All right, so let's investigate a little bit about the type of connection. We have two types basically. We have two types of connection. One is called a point-to-point. Point-to-point is very easy to understand. You know, it's just like just now you have this milk can communication, right? You're using two milk can, you pull a string. So those are point-to-point. Point-to-point means what? Dedicated. One point to another point. So there is a link linking the 2 points. That link is dedicated for that 2 users only. That's why it's actually dedicated. It's called prioritized. Exclusive. You can use the word exclusive for this link is only exclusive being used by these 2 devices only. No one else can come and use it. You know, the moment when you are using it, it is yours. No one else can just come and share. There's no sharing, right? Point to point, no sharing. Okay, so this is actually one of the diagram that's explaining about point to point. So no sharing. Just like if you actually make a phone call using conventional telephone, I'm not talking about using your WhatsApp call or whatever. Using conventional telephone, when you call your mom talking, no one else can call in, you know, right? When you are on the phone with your mom, no one else can call in, no one else can use the telephone. And this is what we call the point-to-point connection. It is so dedicated between you and your mom, right? So this is point-to-point connection. It's exclusivity, it's exclusive. So no one can come and kacau you, no one can come and disturb. The whole line is yours all the time. All right, so this is another way of looking at connection is actually the multi-point. So multi-point means what, you know, you have more than 1 point. That's why it is called more than 2 points. That's why you have multi-points. So you have more than 2 specific devices to share. The most important thing here is actually the keyword is to share a single link. Now you're willing to share with other people. Just like when you get on the road is shared, right? It's not exclusive to you, right? You have to share with other users on the road. So this is sharing. It's the same road, but everyone share. So this is what we call multi-point. Why we want to share? For a very simple reason, it is cheaper. Okay, it is always cheaper to share. You are not going to build dedicated road for yourself. Other people cannot use. So those are point-to-point. A point-to-point is also got the advantage. You know why? Point-to-point is exclusive. You don't have to share with other people, so you don't have congestions. You don't have traffic jam, right? Because it's exclusive. It's wonderful, isn't it? But it's costly, right? So most of our system here require a sharing to bring down the cost. That's why we tend to have traffic jam. We tend to have peak hours, that kind of things. But we enjoy the benefit that we do not have to pay a lot of money, okay, to get our communication established. That's why this is the difference between point-to-point and multi-point. And most of our network, most of our network, not all, most of our network are actually multi-point type of setup, right? Unless you have a very critical network that you would like to set up point-to-point type of connection. Okay, this is multi-point. You see one link shared by 3 workstations to access the mainframe. What is a mainframe? Mainframe is actually a server. The old name for server, the last time they called it mainframe. It is a slightly different type of computers. Nowadays it doesn't exist anymore, but it is equivalent to a server. All right, so let's look at the physical topology. The topology is basically the layout. Okay, so we have different type of layout here. We have a mesh layout, we have star topology, bus topology, ring topology. As you can see that they are actually being categorized according to the physical appearance of that topology itself. What is a mesh? Mesh basically everyone will have a connection to any of the user. Also that is mesh. So there will be messy a lot of cables okay? Because you want to connect to 3 users. So you will have 3 separate lines connect out from your computer. Not just 1 line, 3 lines for 3 users. Let's say if you want to connect to 1,000 people, so there will be 1,000 separate line connect out from your computer. So that is actually the mesh architecture lah. And then star, you know lah. Later you look at the diagram, you know that the topology look like a star. And then you have a bars. Bars just a straight line, okay, just a straight line. So you have multiple people attached to that line. And then you have a ring. So the network is actually look like a ring. So data go in a round robin that of pattern, right? So different type of different type of topology, they will give you different advantage. They will give you different purpose. Which one is more suitable to you? And mesh has been always labeled as the most expensive one because if you want to connect to 5 person, you must have 5 line, 5 dedicated line connected to each of them. So let's say if you have 100, you want to communicate with 100 people, so you need to have 100 dedicated line, so that is actually somehow too crazy, I would say. Too crazy to do because it's to establish each of the line is very expensive. So using mesh topology, unless it is necessary, otherwise you usually will not go for mesh. For example, if you have a backbone server, okay, backbone server, this server is so critical, that's why you want to create a mesh networks to make sure they have more link, okay, more point-to-point link to ensure the overall reliability. So this is the calculation. Let's say if you have how many the device that you want to connect it in the mesh network, so you're using this formula to actually calculate how many port or how many connection you need for one device. So this is a formula, and this is also being asked in our online tutorial. Later you can do a bit of calculation based on this. Okay, so this one also come with example. And so this is actually the mesh network of 5 devices. You can see how many connections are there for 5 devices. It's 1, 2, 3, 4, 5, 6, 7, 8. Altogether 8 connections, you see. And the more connection you have is going to cost a lot more money. Right? So, but of course they have advantage lah, dedicated, you don't share with anyone. These are the disadvantage. And of course, you look at star topology. Star topology is probably the most popular topology around. So because they are using a central device called hub or called a switch. Hub you can never buy anymore. Not in today's market. Hub is too primitive. Then you are usually buy a switch. So to form a star topology, it's really look like a star. Okay, something like this. So most of our network are actually running on star topology. Right. So this is actually one of the popular topology, and you can extend the star topology as well because the cable has got maximum length that you can go. You cannot use the copper cable for more than 100 meters. So if you want to go beyond 100 meters, so you need to have repeaters lah. So all the cables has got their own limitation. So you just need to be aware of the limitation and then provide the network option accordingly. And there's a bus. Bus is actually one of the ancient, very, I would say, older, okay? Because it is actually put everyone, all the computer onto the same bus. So you can see the diagram is just like this. So you have one red color bus there and all the other computers are just connecting to that line, to get communicated. But one problem of this, don't say the problem. Let's say the advantage. One advantage of this is actually you just need one cable to connect all the 4 computers. So there is no fuss. Okay, there's no fuss about, and you can always have a lot of computers sharing one line. But the problem is that when too many computers sharing the same line, then you will start to experience congestion, isn't it? Right, you will congest, right? Because whose turn to use now? You see, now it's whose turn? Is it my turn? No, you say no, it's my turn. I came first. No, you say no, I have a higher priority. Then you guys fight lah. Those will be collisions lah. So for this kind of network, when come to sharing, they always fight. If actually a few people sharing is fine. When you have too many people sharing, there will be too many people fighting. So your network most of the time performance is very low. Because most of the time you spending your time arguing, conflicting with other people, you don't really can spend time to do the transmission because you always fight. Now it's whose turn? Okay, is it my turn? No, say no, it is mine. So when these computers fight among them, to access the cable. So that will be the problem. That's why I said bus topology has become less popular nowadays. Last time when they use bus, it's because they are cheap, you see. But now we can get a switch very, very cheap, you know, like maybe 20 to 30 ringgit for one switch, you know. So why do we bother about bus topology anymore? Right? Last time they you know, this is popular because last time switches are actually extremely expensive. But now you can have these high performance switches at so cheap, at a so cheap price. So this sort of topology tends to become obsolete. All right, tree is a mixture. Okay, you have to put it this way. Tree is a mixture of, you can mix different topology together. Not a problem. Okay. For example, in this one, you can see this diagram here is actually a 3-star. You see, 3-star topology combined together to form a tree topology. Okay, so it's just a combination. And the ring, usually the example is token ring. Okay, so a ring is a network that you can see that they actually form like a ring. So everyone will access the network in the round robin manner. So after this guy, you pass down to the other guy, just like when you play a game, right? So when you play your card game, you know, okay, now it's whose turn, you see? So you go a round robin and look like a good idea, but also having similar problem, very much like the bus topology. Okay, so it's just a different way of sharing. I would say different way of sharing. So now it's whose turn to actually use it. So you place on a round robin manner. So this is ring topology. Of course, if you actually cut one side of the ring, so the ring is not complete, so the data can get stuck at somewhere. Okay, so the same thing happened to your bus here. Okay, if I actually cut the red color cables at one part, so the entire network is going to fail, you see. So they won't be able to actually communicate anymore because of everyone relies on that particular link for communication. So there is no best topology out there. There is only a suitable topology. So if you want highly reliable network, extremely reliable, then you will have to use a mesh network, you see, because a mesh network can ensure, because it is dedicated, isn't it? That's why it can ensure reliability of your network. If your network, you need your network to be highly reliable. Otherwise, you just want a standard network that is good enough in performance, you know, don't have to share like hell. So that is actually using a star topology. Okay, using a high performance switch as the central device. Everyone connect to this high performance switch, so everyone will be happily, okay, getting the bandwidth that they want. Right? So ring is same thing here. So I will leave this one to you. Hybrid meaning to say that you can mix and match different type of you can mix and match different type of topology together. There is no restriction. Topology is just an idea. Okay? It is not a network standard. It is not a network not a network standard. So there is no fixed. It is just high level. So you can mix and match any topology you want. And transmission mode. Okay, transmission, we basically have three types of transmission mode. One is simplex, half duplex, and full duplex. Why do we need to have so many different types of transmission mode instead of just having one? The reason for this, I can safely tell you that, you know, it is because of communication hardware are expensive. So if you are using the lowest grade transmission mode, which is simplex, then you are going to actually save more money. You don't have to spend too much money on simple things. For example, you want to connect your keyboard to your computer system. Most of the time, they are using simplex because the hardware is cheap, okay? And it is one way. Your feedback cannot give you feedback, you see. So only you typing input only. And printer as well. Printers, a lot of times before this, they are all connected in simplex mode. Meaning to say you can only print to the printer cannot print to you. But today is different, slightly different. Today, I think a lot of printers are actually running on either half duplex or full duplex because you can do scanning, you can get feedback from your printer. So those are the things. right? That's why you have these three different type of transmission mode. And then full duplex is the one that we are using now. You can talk, I can talk at the same time, no problem. We're all happy. So you can transmit and receive all at the same time. So this is called full duplex. And of course, obviously, full duplex hardware is more expensive, but not in today's standards, I would say. You know, in today's standards, even full duplex hardware are actually so cheap that a lot of time people forget about, hey, let's forget about half duplex. Let's forget about simplex. Okay, because they make no much advantage anymore. See, after all, you know, those complicated hardware of full duplex has become so cheap, right? So when expensive stuff become cheap, so you don't appreciate anymore. See, I mean, those are the cheap stuff. Okay, so this one I actually give you some of the explanation. I think it's all over there. So simplex is one direction. Half duplex is actually like walkie-talkie. When this guy talking, you have to listen. You cannot talk at the same time. After he say finish, then only you can talk. So you exchange one at a time. You don't both talk at the same time. That is going to cause confusions on the half duplex system. And for a full duplex system, meaning to say you can send and receive all at the same time. Wonderful. Just like what we are doing now, you can ask question. I can, talk about my lectures, and then we all can actually run things all at the same time. So this is full duplex. Most of our system today, they are full duplex, because hardware controller are getting cheaper now. You see, as compared to last time. That's why nowadays your printer also, you are using wireless printing. You are using USB cable to connect to your printers, and those are actually two direction. You know, simplex is just one direction. Okay, those are two direction that of communication media. That's why you can start to see that, you know, your basic stuff like your printers now become more sophisticated. Okay, so different category of network here. We have LAN, MAN, and WAN. LAN, local area. The name tell you that it's only for small local area. For example, if you set up a network for your home, then there's going to be a local area network. Even for Unimas campus, you say Unimas campus is so big, we might have like, you know, so many computers, but it's still considered a local area network, right? So a local network can go beyond something like up to a few kilometers. So that is actually still considered as a local area network. So what is a metropolitan? Metropolitan is citywide lah. Let's say Kuala Lumpur want to establish a CCTV network. Okay, so it will cover the entire city. So that is actually a metropolitan area network. And another one is wide area network. So what is a wide area? How wide is wide? For example, company has got different branches. Let's talk about bank. See, let's talk about bank. Bank will have branches in different states. And some of the bank are actually international bank. They got branches in overseas. So bank do not use the internet. See, I want to bring to your attention is that, you know, the internet is different from a wide area network. Even though internet can be an example of wide area network, but internet is different from a wide area network. Most of the time, wide area network is a private network. You know what is a private network? Private network is not the internet. The internet is a public network, meaning to say that anyone can just join into the network, and then you can just send all your data across the network. So this is public, you see. It doesn't own by anyone. When it doesn't own by anyone, that is called a public network. So internet is a typical example of public network. So what is this wide area network? Usually owned by one owner, you see. For example, bank. Let's talk about Maybank. Let's say Maybank has got so many branches, throughout across the country. So they have all these branches. So all these ATM machine, Maybank branches all link under a single network. And this network belongs to Maybank, and that network is called the wide area network. Let's talk about HSBC Bank. HSBC Bank is an international bank, so they will have branches in all over the different country. So they do not read that, how those branches exchange data. They do not use the internet, you see. You know, that is actually too risky to use the internet for that kind of financial, transaction type of things. So they actually usually build their own network. So they have from Hong Kong, they link to Singapore, they link to Malaysia. Those are actually the network owned by HSBC. So this is also can be called as a wide area network. Usually it is actually not a public network. It's actually owned by some organization. So that is a wide area network. The same thing happened to local area network as well. It is not owned by the public. It is owned by, for example, Unimas campus. Unimas campus network is a local area network. Who is the owner? It is actually Unimas is the owner. Okay, so as simple as that. Okay, so Lan definition, you can see all this definition. Usually it is smaller, limited to a few kilometers only. These are the physical limitations. And then the whole idea is for you to share information. You can use all sort of transmission medium, up to you. You can use copper cable, you can use coaxial cable, you can use fiber optics. In Unimas here, we are using both fiber optics as well as coaxial, not coaxial, it's twisted pair. Right? We're using twisted pair cable to link up the entire network, the entire campus. And you can see the topology of a LAN. It can be a single building LAN. It can linking multiple buildings together. If you look at Unimas, we have multiple building. So all the buildings are actually linked under the same network. So we have a backbone networks in Unimas here. I think our backbone network has got a speed of 40 gigabit per second. And each of the building is running at 1 gigabit per second. And then our internet gateway speed is something like combined is something like a 5 gigabit per second. Okay, so that kind of performance that we are having. So that's why for network it is actually quite complicated. You can mix and match different type of topology together. Okay, the area is mainly covered for citywide. So it's just a larger scale of local area network. And of course, LAN network technology and MAN network technology, they are slightly different, you see. It's not exactly the same type of network technology. They will have a different type of network technology that can allow you to cover a wider coverage area. And the same thing happened to the wide area network as well. They are using a slightly different type of network technology, but usually MAN and WAN, the network technology is more or less the same. It is only LAN, okay, local area network is slightly different lah. But I think MAN and WAN, they usually use quite similar type of network technologies to allow them to cover a very wide geographical area. So we will also study this, you see, network technology for LAN and network technology for WAN. Because MAN and WAN not much different, so we just study WAN, that will be good. Okay, so this is the example of wide area networks are privately owned by one organization, then you call it WAN. But for internet, your internet is not owned by one person, your internet is contributed by a lot of different people from different countries. For example, in Malaysia, probably it is the Telekom Malaysia on the network. So Telekom Malaysia connect to Singapore, Singapore network. Then Malaysia network also connect to Thailand network, you see. Then Thailand network is owned by Thailand, you see. So owned by different people. So we interconnected together. So we share all this infrastructure. So allow network traffic to go through. So those are public network. Example, the internet. Okay, so when we interconnect more network together, such as it will form a bigger network, such as the internet lah. Okay, so for the internet, then we know that it is actually based on for the networks to actually link together, they must speak the same language. That's why they must use the same protocol, and our internet is using the TCP/IP protocol suite. All right, so I think I see a question here. Is there a difference between LAN and PAN? PAN is personal area network. Personal area network is actually smaller area. They are using slightly different technology as well. For example, if you are using Bluetooth, a lot of you like to use Bluetooth, right? Bluetooth earphone, using your Bluetooth connection is actually a personal area. What is a personal area? The personal area is something around maybe 10 meters, okay? Within 10 meters radius, okay? Within your desk on it. That's why it's called personal area network. And then there's also another thing called the body area network, BAN, okay, body area network. So it's actually for sensor lah. When you go to hospital, they put a lot of sensors to actually measure your heartbeat lah, measure your temperature, all those things. They put so many sensors. So that will actually form a, what we call the body area network. So the network coverage is only within your body only, right? So those are, they're all using slightly different type of network technologies. Okay, so these are different. But the main one we usually, when we talk about computer network, is always LAN, MAN, and WAN. Okay, LAN, MAN, WAN, and plus the internet. And those smaller scale network is actually serving personal. You can talk about it lah. It's not an issue, but usually we don't put so much attention to it. Yeah. All right. So for each of the network operators in the internet, we call it the internet service provider. Okay, this internet service provider in Malaysia is called TM. Okay, Singapore, maybe you have Singtel, you know, so you have different, you will have different people, okay, different operators in different country, so they link the network together. So this is where you get the internet service from them, like you subscribe, you say you subscribe. For example, you subscribe Unify from TM. So Unify is an ISP. They give you the internet, you see. They provide you with the internet, but you have to pay money lah. So they are the internet service provider. So you are the subscriber. You subscribe, they link the network to the internet. They link you to the internet. Okay, so those are the internet service provider. Okay, so this is actually the entire structure lah, of the internet today. You have different ISP. In Malaysia, it's not only TM as the ISP. You know, you can have Maxis, Celcom. All these people are all internet service provider. Okay, and then they all maintain their own network. Sometimes they all interconnect to each other as well. That's why the internet is very complicated. If you ask me how many nodes in the internet, no one knows, you see. Basically, the moment when you switch on your computers, there's a new node in the internet. Then the moment you turn off your computers, one node's gone missing. But it will not affect the internet, you know. The internet will still operating. Even if one of the ISP breakdowns, due to earthquake lah, due to war lah, like now Ukraine being bombarded with a bomb, then the internet infrastructure being destroyed. It will not destroy the internet, you see. The internet will still surviving, you see. It's only that part of the networks got damaged only, right? So that is the beauty of the internet. That's why it's a network that cannot be destroyed, at least at the moment lah, because so many people contribute to this network. And if you know the history, this network is actually a military network that was built so that, you know, you cannot destroy, the enemy cannot destroy your network during the war. Right? So this is actually this network being evolved into today's internet. Right? Protocol, as I mentioned to you, is a set of rules. It's the language that all computers must speak. So for you to be part of the internet, you must speak TCP/IP. All the computers, including your smartphone, your smartwatch, everyone's to be part of the internet, all of them must speak the TCP/IP protocol. Okay, so TCP/IP protocol is the only protocol that is being used for the internet. So, in simple terms, if you want your computer to be able to communicate in the same network, all of them must be running the same network protocol. Okay, standard I mentioned to you is mainly for hardware manufacturer. You need to maintain a standard. You buy a keyboard from anyone, you plug into your computer system, your keyboard will surely work. So the same thing happened to your network adapter as well. You have so many different type of manufacturer for network adapter, but as long as they comply to the same standard, you just buy and plug in, they should work seamlessly without any problem. And we have two different types of standard here. We have a de facto standard and we have a de jure standard. De jure is actually by the law. You already set the standard, everyone follow. De facto means it is not yet have standard. The standard is not even finalized, but because I am the biggest manufacturer, so I keep on pushing my product to become the standard. So that is actually what we call the de facto standard. Because I control the biggest market share, so I have the same power. I said that, okay, since I have the biggest market share now, so my product is going to be the standard for this kind of purpose. So I can say that because I have a lot of market share. Okay, a lot of people buy my product. So I will become the biggest, supplier. So I can set my product as a standard. Right? So there are two ways for you to set the standard. One is by the law. Everyone sit down, discuss. Okay, we adopt this one as standard, so everyone follow. And the other way around is actually there are some guy already start playing the game, start dominating the market. Then they claim that that is the standard. So people may say that, oh, since you have already in the market for so long, so many people recognize your product as the, as a de facto standard. So your one will later become a formal standard. So this is actually what happening. Right? So standard got proprietary and non-proprietary. One is owned by someone, clause, do not share. The other one is open, okay, open standard. So these are quite common. And of course, in order to come to standardization, you need to have regulatory body to actually regulate all this standard. So these are the list of standard organization who actually, regulate on the standard. They all sit down to discuss with different people, different manufacturer, different researcher, different governments, and then try to finalize on the standard. So these are the different organizations. Okay. So is there any questions? Am I going too fast? These are just important points that I highlight. See, you can have the video lectures to give you the lengthy version of the lectures. That's why I said this is something extra. Is there any question that you would like to ask? Any question? I know your friend just now asked a question. What's the difference between LAN and PAN? LAN stands for local area network. PAN stands for personal area network. Personal area, something like your office desk. When you sit on your office, you got your computer, you got your laptop, you got your smartphone, or all these devices can communicate among themselves in a very small area, which is actually less than 10 meters. So those, we call them personal area network. A question saying that what does it mean by the internet port is mature? Internet port is mature. I don't quite get the question. Okay, I think the internet ports thingy, let me explain a bit. Internet ports. Internet ports essentially go by the layers. So if you have higher layers, so if you have higher layers of for example, at layer 4, so all the communication is all go by the ports. You see, these are all software ports. You see, and then the software ports, there is always a limit. There is always a limit of the number of ports that you can have. I think it's something like a 64,000 ports. And so when you using too many ports, then there'll be run out of ports usually. But I do not know exactly what you mean. But I need to listen to the context of what you mean by internet ports is mature. Okay, never mind. We just go to the next questions. Okay, semantic and syntax. Okay, semantic is actually the meaning. Okay, the meaning and the connection of the thing, and the syntax is actually how you doing it. You see. Okay, so I think don't worry about so much this one. This one is too theoretical already. I think it's sometimes you're gonna make you confused about these two. But then later when we go down to the details, then you will start to see the meaning of this. If I explain to you at this level, then you will still get confused again. I can explain the meaning, but you won't get to see what is that. Don't worry, later when we go down to each of the details layers, then you will see, what does it mean, you see. Yeah, I think you heard about the internet port is mature type of things. I think I need to know exactly which part of the video and at what time, then I will be able to get to it. If you actually put like that, then I won't. It might be tied to certain context. But I mean, if you can later provide me, at what time the video, at which point, the time of the video, I mentioned about this, then I can go there and then I will listen. Then I will be able to tell you exactly what it is. explain what are fault identification and fault isolation. Okay, fault identification is actually whenever there is a problem. For example, cable break. Cable breaking is actually a fault. You want to know where is the fault happening, so you need to go through fault identification. Then once you know that there is a fault, for example, I just give you an example of our traffic system. Okay, when we have a traffic system, suddenly there is an accident here, right? So you know that there is a fault. Okay, accident is here, so you identify the faults. And then you want to isolate this accident from the other, so you do a rerouting lah. So when you do a rerouting, that is actually called the fault isolation. So you isolate the fault so that your data will not pass through that one, or you will not pass to that location anymore. So it's actually you isolate the fault outside of your transmission path. Okay, so that is actually the differences between fault identification and fault isolation. Okay, it's basically very common when you go into problem with your network, certain part of your network is actually faulty. Then once you can identify them, then you will try to isolate this problem outside of your network, so that your data will not keep going there. You see? Okay, so I hope this is clear. And then these are actually quite general but of course there are different techniques that we're going to talk about when we talk about the detail of each of the layer. Then you will see there are different techniques that they are using on how do they mitigate faults in the networks. Okay, so I have question for you actually inside Ellipse. We have the online what we call the online tutorial forum. I actually posted a few questions there, so I would appreciate that for some of you who haven't been there to actually take these opportunities to actually go there to answer some of these questions. If you can look at your friend's answer, if you agree or not. If you do not agree, you can comment on your friend's answer. That is even better, because this is a learning process that you do not take the fact directly just like that, but you explore based on your understanding, then to judge certain answer whether it is correct or not. So I would really appreciate that. That will really help you to understand better. So you don't just listen. Listening sometimes, you see that, oh, this one sounds good, I can understand, and but how much you can understand, is not until you answer some questions. So the moment when you start to realize that you don't know the answer to certain questions, that means that you still got stuck somewhere, and you still need further understanding. You haven't been understand enough. Okay. All right. Any other questions? Oh, network backbone. It's just another network, okay? Backbone network is just another network connection. Usually people use a higher speed network connection for network backbone. It is something like, just like highway, okay? You can put it this way, okay? It is something like a highway. Network backbone is like highway. So those smaller roads connect to the highway is called, normal network. So when they're actually being linked together by a highway, then the highway will become a network backbone. So when you hear about a network backbone, it's actually an important network that linking all the different network together. So that is a network backbone. So for Unimas here, we also have our network backbone here, which is actually a network that is actually 40 gigabit per second. So it is actually linking all the network from all the different buildings, all linked to this network. So this network is a super highway, so you will actually be able to link everyone together. Yes, I would say that it will link different lower speed network together. Okay, usually a network backbone tends to link all the smaller or what we call slower speed network together. So that is usually what we call network backbone. So usually a network backbone will have a higher speed. Okay, it will have a higher speed. And again, very much depending on how you design the network. There are so many ways to design a network. It's all based on your creativities, right? So a lot of possibilities. Okay, so I just want you to get the overall pictures. The whole idea is the overall picture is more important because we're going to talk about the details in our learning unit, learning unit 3 and above lah. Our learning unit 3 and above, we're going to see all the details. Yes, I mean, if the network backbone fail, okay, our friend asking about if the network backbone fail, what happened, you know? If the network backbone fail, so the part that have failure, then the data cannot pass through lah. So only the data can go through a very smaller area. It cannot go through the backbone. Sure, you have communication breakdown. Well, I'm sure you have communication breakdown lah. So it's going to break down a lot more networks like that. That's why network backbone, usually you have to keep it as reliable as possible. Okay, another question talking about dial-up networks uses token ring. No, the dial-up network is not using token ring. Okay, dial-up network is actually interconnecting a telephone network with a data network together. Okay, so you are transmitting data over a telephone network. So usually it is called a dial-up network. There's an incoming call, it will interrupt the home networks. Usually it is not like the moment when you are actually connecting to a dial-up networks, you occupy the line, you occupy the telephone lines. So no one else can call in. So the moment, as long as you are on the network, on the dial-up networks, and you didn't hang up, then no one else can use that network. For example, back to last time, how we get access to the internet is that we have to through a network, but there is no network cable all the way pulled to our house. No, the only network we have at home is only telephone network. So we take advantage of the telephone network. We just buy a modem. We buy a modem, connect to our telephone networks. Then this modem connect to our computer system. Then we can do dial-up through the telephone networks to another server sitting over the other end of the telephone networks. Once that connection is established, you are just like talking, making a phone call to someone. So you have to hang up so that other people can actually use the telephone line. Okay, so this is actually what happened last time. That's why when you get online on the internet for 3 hours, then that 3 hours you occupy the telephone for 3 hours. No one else can use the telephone line. So you are basically disturbing other human being from receiving voice call. And your mom trying to call home, cannot get through. Your mom is going to get very angry. That is the problem last time. But now today's, if you are talking about streaming, streaming is also using our telephone line, but it is not a dial-up. It is not a dial-up connection. It is a always-on connection. See. So when it is an always-on connection, you can have your internet on all at the same time, and your telephone can still be used as normal because they run in parallel. Okay, they run in parallel. These two connections, the data network and the telephone connection, run in parallel on the same line, and this is a technique what we call multiplexing. You're going to study this in one of the learning unit, and it's called multiplexing. Which topology is the most fragile against link failure? Bus is fragile. Bus is extremely fragile. And then ring is, it is connected in the ring, right? So it can still move in one direction. So ring is not as fragile as bus. So bus is just one connection only. So it is very fragile. So I would say, personally, bus is the most fragile. Ring, if actually break at one point only, you can still go the other direction, you see. So ring, if you configure them nicely, then it is actually more reliable, slightly, I would say slightly more reliable than the bus topology. Bus topology, just one line, one of the line breaks, that's it, everything gone. Everything gone. Okay. Any more question? Yeah, I think you will have a lot of questions along the way, I would say, because we are going to cover the details of each of these layers. So when we come into the details, you can start to see. But I want you to see the big pictures. Even if you cannot remember all the details, that is still fine. As long as you can see the big picture, then you get the overall understanding, then that is actually very good. A lot of people study the details. They go and memorize all the details. But at the end of the day, because you're just memorizing the details, you cannot remember the knowledge for too long, you see. That's why you need to have a map in your mind to see the overall picture. Once you see the overall picture, then the moment when actually smaller detail come into the picture, you can put them accordingly, so you won't get confused. You won't get messy as well in your things. And one of the things that I want to warn all of you is that, you know, this course CCN is actually is actually a very it's actually quite a very complicated course here, because network has the longer history than the computer itself, you see. So you will see different type of technology that is being used. Some of the technology come and go, not become popular, become less popular. People don't want to use, and new technology come by, and things like that. You see, even I think nowadays, all the network that you are using, including your internet at home, your Unify, your 4G, your 5G, they are all part of this. You see, they're all part of this. Your Wi-Fi, they're all part of this. That's why it's a very complicated system. I would call it a network system. Is quite complicated as compared to a computer system. The computer system is only probably having 60 years history, and communication networks, they all borrow each other's. They all borrow the technology from different type of communication network to form today's network. That's why they will have history more than 100 years, you see. So I would say it's quite complicated. But I think we try to make life straightforward and easy. The most important thing is actually you get to see the overall pictures. Then that is good enough already. All right. Any questions? No more questions, then we can call it a day. And then for some of you, you can just pay a visit to our online tutorial today. Then tomorrow you can take our session to study, to look at the video lecture for learning unit number 2, which is available already. I already make it available just now before the lecture. So we will discuss learning unit number 2 next week. Okay? Is that right? Okay. Okay then. Then for those of you who haven't scanned your attendance, I will post the attendance again. So you will scan your attendance.